Alright class, in this homework hints video for section 5.3, Math 2020, I will go over, give you some hints on problem number 1, number 7, which includes exercises 3.2 and 3.3 in the section in the book, and 14a, which talks about the volume of a kite. We didn't cover the volume of a kite in our lecture video, but it has a quite nice investigation. So number 1. Number 1 says that we are to draw an obtuse triangle and show the 3 base-altitude pairs, making 3 pictures if necessary. So what I'm going to do is I'm going to do 3 pictures and an obtuse triangle. Altitude is another word for height. Okay? So let me go ahead and draw my first picture of an obtuse triangle. Now the obtuse triangle from the section looks kind of like this. It's like oriented this from the section handout. Okay, we have an obtuse angle right here. I'm going to draw in the points here. Okay, and we're going to show different base altitude pairings. Now, in order to find the height, which is the distance from the base to the top apex of the triangle, or the top point, you need to determine what the base is, and then from there, derive the height. Okay, so the base is going to be right here for the first orientation. And I'm going to drop it down let me use a different color here, just for fun. Okay, and so I'm going to drop down the altitude, which is going from the bottom to the top, or the top to the bottom, at a right angle. Okay, and so we have these pairings here. Now the height is right here. Oops, I ran into my arrow a little bit here. Okay, that's the height. Okay, so that's picture number 1. Now in order to know picture number 2, think about this as 3 sides. Now each of the 3 sides need to be a base. Okay, first is the short side as the base. Okay, so we'll write short side here. The next is the medium side. Okay, so I'm going to write medium side here. And then you have the long side. So write the long side here. Each of them have to take turn as the base, and you need to see what the corresponding height is. Okay, so we're going to rotate my figure so that the medium side is the base, and that's this one right here. And my short side is gone here. So I've rotated it a little bit counterclockwise. Okay, and there is my long side here. The medium length side, the short side, and then the long side. Okay, so now my medium side is the base, and where would the height be? Well, the height is again from the bottom to the top. Oops, let's label my base first. And I use this as my altitude here, my height. Okay, so base and height. Okay, so there's my base and height. What we're going to do now is we're going to go ahead and rotate our figure again. so that the long side is now, rotate again counterclockwise, so the long side is the base. Okay, so that would look like this. Okay, so there's my base. There's my long side as the base. Here's my medium side. And here's my short side. Okay, and then the height is going to be right here, inside the figure, whereas suppose the other ones are outside. Okay, so there's 3 different ways. Now why they're doing this in the book, and they set this as the first problem, saying that any side of a triangle can be the base. Okay, and if you get stuck on your homework, as far as like where's my base and my height, because my formula is 1/2 base times height, turn your book around, different rotations, so you can see different sides as the bases. Okay, any side of the triangle can be the base, and the corresponding height can be derived. So you might have some measurements for other sides as bases than just when you have your book oriented straight up and down like normal. Okay, so that's what they have for that one. Now I'm going to do a comment on exercise 3.2. Exercise 3.2 in the book has a diagram that shows 2 adjacent squares. You want to find the area of region R, which is part of those squares, in 2 different ways. Okay. Part A. Find the area of region R using subtraction. Okay, so I'm going to draw out region R here. Okay, because we have our region with 2 different squares. Okay, so there's the first square. This square is a 4x4 square. The next one is a 6x6 square, so it's going to be 2 meters taller and 2 meters wider. Okay, this is going to be 6 meters here and 6 meters up here. Region R is the diagonal of the first square. I missed that a little bit. Okay, and the diagonal through the bottom part of the 2 squares here. There we go. That's region R. Okay. All inside here. We can color that in a little bit. I'm going to do this in black. This is region R. And let me try to use this one here to shade it. Oops. Okay, here we go. Yeah, here's some good shading, like a color pencil. Okay, that's region R, all of this. Okay, what are we going to do? We need to use subtraction to find the area, which means that I'm going to take the area of this square and subtract off the green part here. Okay. If I subtract off this green part, right here, then I can find the area. Okay, so there's a green part there, and I'm going to subtract off the red part for the other part of the square. Okay, if I subtract off the area of the whole, all of the squares, right here, they're just right, this whole thing here, and the red part and the green part, then I can find the area of region R. Okay, take off everything that is not R. Okay, so the area of R by subtraction is equal to the area, oh, sorry about that, is equal to the area of 4 by 4, 4 meter by 4 meter square, plus, oops, plus the area of the, oops, let's go, we're running out of room here again, of 6 meter by 6 meter square, okay, so you add those areas up and you subtract off the area of the green triangle, plus the area of red triangle. Okay, you have to put those two together first. Put those two and put the squares together first, then subtract them, okay? So it's a several step process, all right? Good. So that's the area of the region by subtraction. Part B says you need to divide the region into two triangles. So the area by dividing R into two triangles. Okay, and so what we'll do is I'll go ahead and recreate R, because we'll have to divide up a different way. Okay, this is my 4 meter by 4 meter square. This is going to be my 6 meter by 6 meter square. Again, region R was found by drawing the diagonal here, and then the diagonal from here. Okay. This is region R. I'll put the R up here. And I'm going to shade in region R using my color pencil. Okay. All right, so this is region R, and it needs to be divided into two triangles. Currently, it is divided into two triangles if you think about this as the division right here. Okay, and if you think about this as triangle 1, oops. Think about this as triangle 1 with, let's do red here. Okay, and this is triangle 2. Triangle 1, triangle 2. Now, what we need is a base and a height when we do these triangles. The base could be any side. We know that this is 4 meters here for this triangle 1, but the height, I don't know what it is, because it starts at the bottom here and it doesn't go all the way to 4 meters, which is the total height of the square. Somewhere in between, but we cannot determine it. It's not given to us. Same thing with triangle number 2. The base could be this one, or it could be this one. Probably not any of the diagonal ones, but probably this base here. But we know that this could be 2 meters for this little distance, but how much is this? We don't know. So that means we need to redivide region R into different triangles. So we're going to back up all of our thoughts here. And it turns out that this is the trickiest part of the problem, it turns out that if you split it in half like this, and two parts like this, then you can have triangles that will work. So here's a triangle here. They will work because we can find the base and the height. We can derive it. So I have a red triangle here, which I'm going to overlay with my red colored pencil. Okay. Okay, so this is triangle number 1. Okay. And in yellow, let's do purple, Weber State purple. We're going to outline the second triangle here. Okay, so I'm going to erase the R. Whoa. Yeah, I can erase the R without everything. Okay, so that's triangle number 2. That we're going to do in purple here. Okay. There we go. Okay. And so we have a base and a height for each of these triangles. Okay, they're obtuse triangles, and so some of the heights might be derived outside of the figure. Now the area of region R is equal to the area of triangle 1 plus the area of triangle 2. Okay, so you find those areas, make a base and a height, and you can add them up for that problem there. Okay, the last one that we're going to talk about, oh yeah, we need exercise 3.3. Common question here. And go ahead and draw out exercise 3.3 here. So it's a rectangle. Okay, and then in this rectangle we have diagonal here, diagonal here. So that one looks pretty bit small here. It's like right about there. Okay. And then here is S and another one for T. And T is smaller than that. There we go. Okay. Do region R here. And this is R in blue. Okay, that's region R. And then we'll have region S in red. Okay. And then we'll have region T in green. Okay. Now what we need to do is we need to think about what it says the hint. We need to find the area of S and T together, but the hint says that we need to skew S so that it butts to T, which is kind of a weird phrase. We just need to make them adjacent to each other. Skew it so that it goes right up against T is what it really means. So let's go ahead and draw that here. So I'll draw a depiction of it, where we'll redraw the rectangle. Now there's a space here. Let's see, I missed some labeling here on the first one. 3 centimeters, and this is 3 centimeters. So the white space will come together at 3 centimeters, and S and T will also come together. So here's S and here's T and here's R now. This right here is still 3 centimeters. This right here is now 3 centimeters. And up at the top of each one is 8 centimeters. Okay, so let me get this guy down a little bit more to have room for our labeling. There we go. Okay, so R is blue. And we have that the area of R is going to be, 16 centimeters squared. Okay, so helpful information. Now S and T have a base and a height. Okay, so we need to find out what that is. Okay, base is this right here. The height is here. Okay, so find out what the base and height are. We can use clues from R and others as well, other parts as well. So that's my hint for that one. Okay, so after that one we have 14A. Now in 14A we're looking for the area of a kite. We want to use the fact that the diagonals of a kite are perpendicular to prove that the area of a kite is 1/2 CD, where C and D are the lengths of the diagonals. So let's try to draw a kite here, and so we can see what they're referring to here. Okay, so here's our kite. Now, the diagonals is what they're talking about here. So we're going to draw in the diagonals. One is called C and one is called D. Okay, so we can call this one C and this one D. Okay, we're looking at areas of triangles and so on, and so we can use these triangles to find the area of them. Okay. So take a look and see if you can find the area of the triangles using the triangles. Now, area of the triangles need base and height. So we can divide them up into 4 triangles, but do we have enough information to do the base and the height? So if you have this triangle right here, that's in purple, which is the same as this one right here, do we have enough information for base and height? Well, let's see. We have the base could actually be equal to 1/2 of D. That's true. This is split into 2 equal parts. But the height is only a part of C. Okay, but how much? Well, it could depend. It depends on how skinny it is. So we don't have any way of knowing that. So we can't divide the triangles up into the kite up into these 4 triangles. Okay, same story for this one. We can have the base as D and 1/2 of D. Okay, the base could be 1/2 of D. but we don't know the height. Okay, so we're going to back up. We can't divide them up like that. What happens if we divide up into two triangles that are the left and right sides? Okay, so on the left side, I'm going to make a green triangle. Okay, that will be like our triangle 1. And highlight it green here. And then on the right side, I'll have my triangle 2. Okay, outline this green triangle number 2. Okay. So do we have the information we need, to get these triangles? Their things. Okay, so we have, let's go back to here. So the area of triangle 1 is equal to 1/2 base times height. And it looks like triangle 1 has a base of C and a height of D. Oh, that looks interesting. So it looks like we have enough information. Well, not D, sorry. D is going to be half, height is going to be half of D. We do have that. Okay, so I'm going to outline here to show you where the base and the height are. The base is all of this, which is in red. Here's the base of triangle 1. That's all of that. The height of triangle 1 is from the bottom to the top. Here's our apex at a right angle. And that's half of D. Okay. Same story for triangle 2. Here's the base of triangle 2. And here's the height of triangle 2. Okay. I'll back that up a little bit. And so the area of triangle 2 is equal to 1/2 base times height, 1/2 of C times 1/2 D. Okay, so we have those areas. We need to be able to derive the formula 1/2 CD from both of those. So if we add those together, maybe that would happen. One other way that's fascinating is that you can use the diagonals to show the area of a kite using a rectangle. Okay. Okay, so I'm going to draw my diagonals again. Okay. And I'm going to take this piece here, let's take red, this triangle here. Oh yeah, we label this one is going to be D, and this one is going to be C. Okay, there's C and D. Take that triangle that is red and put it over here. Now when you do that, it will be in a congruent triangle, and it will make a part of a rectangle here. Okay, because the kite, this side here and this side are equal. Okay, and so the triangle can be put over there. Okay. Okay, so here's this red part here. And it's the same as this red one here. Okay, they're the same size. And we'll do that with this one right here. We'll just make it, we'll use yellow. And this yellow one, this yellow one can also go over to the other side to make a rectangle. Okay, they are the same size because these two sides are equal right here. Okay, so they can match up nicely. And I'm going to color in this part right here. and then this part right here. So the red and yellow shaded parts with colored pencil are the rectangle that we can use to find the area of it. Okay. The rectangle has a base and a height. Okay. So the area is equal to base times height, which is equal to what with respect to our C and D? Okay. That's what you can figure out here. Okay. So there's a couple of clues for 14. All right, so this is the video on that homework hints. Let me know if you have any questions.